everyone, welcome to this screencast where we build a beautiful to-do command line application in Go. So if you are new to Go and you're looking for something to practice, this is a good one and I think you will love it. So before we start writing code, I would like to show you what we'll be building in this course. So I've compiled the app and the app is on my desktop. So this is the app. You see that it's currently saying valid operation, so we need to pass it some command. So let's say add recording screencast. Let's recording, just keep it short. Take a walk and what else? Test to do. So I have 3 to-dos added to it now. We can issue the list command to show all our to-dos. So right now what you are seeing is because I've added some to-dos previously, but as you can see, you see the ones that we just added. 1, 2, 3, 4, 5, 6, 7 looks beautiful, and we finished 2. This is what we are building, and we can of course mark some of the to-dos as completed by saying complete. So let's make the test to do 9 complete. I will go ahead and do list. Let me clear my screen and do it again, and as you can see, it looks really beautiful. So we can of course delete it to do by saying delete equals let's delete the second one, reply emails, and then I will list again, and you see that the reply email is gone. We're currently using a JSON file to store the data. So as you can see, the data is stored using JSON. So I will show you in the screencast how to read and convert this to Go data structure and how we can use it to build out this beautiful interface on the command line. So stick with me in these few minutes of screencast and you will learn how to build exactly what you are seeing on your screen. Fantastic. So there's currently nothing on the directory, so we're going to start bringing in our folders. First thing, let me use the make dar to make it faster. It's faster than typing all the directories. So we're going to have cmd/todo. So this is our main package where we're going to have our executable. We're also going to have a touch make file. I think we can keep it simple at this start. So expand the folder. Let's also do go mod init. I'll put it in my GitHub namespace. I just name it to-do app, and it's asking us to run go mod tidy, so which I will run. Alright, I think everything looks good from here. So I'm using Go 1.18. Next step is to add some code. So this is the main package. So I will say main. So this is our main package, and of course let's print the hello world. Alright, so this is hello world. So we need to run this. To run it, I would like to type make run to do, and then it should run. So let's go at that target to run to do, and then we do go run cmd/todo. The make command should not work. We should see hello world. Fantastic. Next step is to work on the data structures, which is our to-do items. So I will come here and create a new file. We can create so if you like, we can actually create another folder, but I'll just create it directly under this one, to do, which is the main data structure. So we have a to-do package. Type, let's have an item type of struct. The task itself, if it is done or not. This is Boolean. The time it was created and the time it was completed. I think this is good. Also, we need the list, a collection of items. So this is the main to-do list. So we can say type func, name it to do's, and it's of type slice of item, right? Next step, we need to add methods to this, like how to add to do, how to delete it to do, how to mark it to do as completed. So I will go ahead and say function pointer to T and to do's, add the tags we are adding. We're not returning anything, so to do will be item, the task like we put up there, the task, done will be false. Actually it's false by default, so you can leave that out, but yeah, created at is time.now and completed at, I'll leave it at the default time, which is this empty struct. So now that we have this, we need to append it to the list. To do that, we need to dereference the list because we are using pointer here, and dereference, and then add the to do. So that is the add method. The second method we are going to work on is how to mark it to do as completed. So func, same signature, so we just copy this quickly to make things faster. And then we need the index, which I will say index int. Add some space here. So let's get to reference to the main data structure, which is this one. If our index they are passing is less than equal to 0, just little check here, or it is greater than the length of the copy, we want to return error here. So that means we can errors.new or whatever, invalid index, right? If the index is valid, we just do ls the index minus 1 completed at time.now, and done, we need to set done to true, so we just copy this quickly. And of course, since that is the case, we just return me if everything works. Alright, the next method we are going to work on is the delete method. Let me make some room for myself. So func, bring this, sorry, I want to bring this here again. Don't mind my laziness. Return, we're going to do like similar thing here, and we're going to now do the referencing again. This time around we do this one. Basically we are slicing from beginning to index minus 1, and then we spread the rest across. Index. Let me not miss the column. Alright, so this is going to set the list to everything minus the index, the one that has this index. So at this point we can return nil as well. What else? We need to do so we can add it to do, we can mark it to do as completed, we can delete it to do. So what else do we need? How about loading the to do from file? How about writing it to the file? So, alright, so let's first of all load it from the file system. So function similar signature again, and I will call it load, the name of the file name, potential error. So file error IOUT dot read file. So goal is deprecating IOUT, so we have to be careful with it, but it still works. So if that is the case, we return error. At this point, we have the file. This error can be two different things can happen here. One is if it's a file not found, no problem. That means we've not error is. That means we've not created a file and our application is just starting and all that. OS dot error not exists. If that is the case, no problem. I will just return new here. If not, we return an error. At this point, we just check the length of the file too. If it's 0, we return nil because that means nothing is in the file, and it's not really an error. That means we don't have any to do in there. And then the next step is to convert the data from here into the struct object. So basically, we are about to unmarshal that data into the list. That one is quite easy. Since we have error defined here already, we just do json.unmarshal the data into the data structure itself. Of course, we check for error again. If error is not new, we return the error. At this point, we can return new. So this is the loading code. Basically, just load the file, read the file, unmarshal, and exit. No problem. The next method we are going to work on is how to write. So when we load, when we add the to-do, we also need to write it back into the file. So we need another method called store. And I'll take file name again. Anytime you're doing anything with files, you're probably going to have an error, so always return error. I would say data error is basically we're going to marshal this, so I just do json.marshal and pass in this. Of course, we check for an error again. If we have an error, we return that error, else we have the data here to write back to the file. We can just return IOUT.write file, the file name and the data that we want to write, and then the mode. This is 0644. This is the permission, right? So this is good. I think we have all the code now for our to do. Next thing is to go and write the main method so we can start using it from here. So the const, let's say to do file will be, we can just name it to do's or JSON. If we want to keep it hidden, we can put a dot before it. Let's make some flag. Remember from the demo we had an add. So flag, just to see if it is true. If add is true, then we're just going to add it first by default. Add a new to do, right? And then I'm going to say flag.pass. I want to take it one thing at a time. We'll come and add more here, but I want us to take it one thing at a time. So I will say to do's it's a pointer to to-do dot to-dos, right? So this is the list. Remember the list that we've created here. So this list, these are our to-dos now have all the method that we created earlier, so we can use it now. Alright, so time to say if we have, let's try to load the to-do when we start the application. To-dos dot get or load, sorry, and then to-do file. If we do have an error, this is the time to exit. So I will print something to the standard output fprintln. I will say os.std. Standard error actually. So I print something to the standard error, which is the error message I got. I print it to standard error and then I'll use os.exit. I'll just exit it one. Alright, after that we can do our switch. So if we have let's say case add, what we want to do, we just want to add to-dos dot add, what is the tax, let's say sample to do, right? Let's keep it this simple for now, default, and then default I will do something similar here, but this time around I'll do std out. Std out, it's not really an error, but invalid command. I just exit gracefully. So let's test the code we've written so far. We can do go run add to test it, but nothing is going to happen because don't forget, let me show you why. Don't forget, now we've added, if you go to the add method, so we've appended the data structure to this our list, but we are not saving it yet, so we need to save it. So we need to go in here. After we do that, we should save it by saying error is equal to to-dos store. We are storing it to-do file, and if there is an error, we just do the same thing here or something like that. Alright, so let's run the code again. And now you see that we have a to-do.json with our to-do created. Fantastic. So the next step is to add more flags so we can do a to-do. How about complete? So to mark a to-do as complete, we can do an int complete. The index will be 0. Mark a to-do as completed. So with that, I can come here, case a complete is greater than 0. That is when we want it. And we can actually say greater than 0 and less than equal to the last high, if you like, greater than 0 and add the rest of it here, but it's okay. We need to dereference. So how to mark it as completed is basically doing the same thing to do's. I think that returns an error, so we can do error to do's.complete, passing it the complete, which holds the index, right? Very important that you hold this index. And if you notice, we have to continue doing this saving. We have to do very similar thing here and there. And for me, this is becoming repetitive. So what I want to do quickly is to do some this. So we'll come back and refactor. Let's just continue building. We'll come back and refactor. So let's do now complete 1. So we go into our to do. Let's look for done. Task done is false. Completed at the default timestamp. So something is not working. Let's look at it one more time. To do mark complete. We then we're not saving it. We're not saving it yet. So we need to save. We need to store it back. And this is why I was saying that this code is becoming, there's a lot of duplicate here now because of error handling. We need to remove this. So let's run it again and then go back to the to do. You see now that it worked. So let's just do a quick recap for in case you are getting confused. We have 2 flags, add and complete. We just pass the flag. This is standard Go way of doing things. Then we initialize our to do here. This is the to do structure that we have here, right? Then when the application runs, we try to load the to do. If we find a file and load it, great. Then we just populate this data structure. But if there is nothing inside, no problems. Then we are switching. We have 2 cases now. One is when a user wants to add a to do, we execute this portion of the code. When the user wants to mark a to do as completed, we execute this portion of the code. And for this add, we are just calling the add, and then we are calling store. We're calling complete, we're calling store. So most of the methods will follow similar pattern. So the third one is the delete. Delete is simple as well, but we have to do the same thing. I'll just name it there. And then delete is very similar to this because it uses an index. Delete a to do. Alright, so to delete a to do, I'm just going to copy this whole block and mark it as delete. So we are using the delete now. When we try to delete, if we run into an error, of course we exit. Else we try to store it back so that we can persist the changes we've made, and that is it. So let's run it again. And right now we have just one to do, so let me add one more. Adding another to do. Alright, so we go back now. We have 2 to do. So how about we delete the first one and delete 1, so it's gone, right? We can go again and delete. Everything is gone. So it's working. All the methods are working. We can add them back. Short more to do's. I think let's add a little bit more so that we can implement our list. So we have 3 here. Time for us to add another flag called list. And this list is, it can be anything. We just make it a boolean. So when the list is set to true, we should list all to-dos. So we take the list and go back. Similar to, anyhow, let's come here. Case. Oops, I want to put in bracket. Alright, so what we want to do, list is basically, I will just say to do's.print. There's a reason why I'm doing this, because I think we're going to write more code in order for this to work. So what I'm going to go and create that method. right now what we can, let's say for item range over T, just the underlying data structure of T, and we just do print F is what I need. This is the index, this is the to do itself, and then we put new line. It will be the index item.task. Because I want the index to start from 1, I'll just increment it there. So here now we just do list, and then we see our grid to do's. So sample to do, sample to do, sample to do. Is that what we have? Exactly. Because it's a test file, you can edit it like, take a walk. And then when you run it, take a walk, right? That means you can modify the file as you like, but you want to be careful so that you don't make a syntax error here. If we make a syntax error, we'll see, let's make a syntax error. We should see an error from the invalid D after, yeah, so code works. All right, so we have the print method. The print method needs more code, and we'll come to that shortly. But also, how about this idea of, say we want to write echo add new to do via pipe. How about when we want to do this? Of course, we now run our to do and then pass this. So we need, let's implement this, then we'll go back and implement the print. The first thing I want to do is to work on the new method. So I'll call it, let me just put the function here, get input. Get input. We're going to read from the IO reader, and then all the args. And we return error, sorry, we return a string or an error. All right. Args. All right. Okay, so if we have some argument, so basically if you type, if they do this, we take that instead of the pipe. So if len args greater than 0, we just join everything and return it. String.join, we join args by empty space, and then we return it. That's good. This is the case that we have right now. What you're going to have right now. So we're going to replace this with it. Then next is the buffer. So we're going to say scanner buff IO new scanner. So scan, we are going to read from this scanner.scan. This is just to give us the opportunity to read from the a standard input of the other program. There's nothing too complicated here. If scanner.error, and error is not me. If we do have an error, we want to return this. If not, we check the length of the test. Scanner dot text. If it's empty, we should return new error. This error is not going to be near at this point, so new empty to do is not allowed. Alright, at this point we just return the text. And another way is to say text. read this once, and then we do this. That way we are not executing this text twice. For me, this is better. So we need to take this get input method now and use it in our add section. Alright, so we're going to sort of rewrite this. So the task error is get input. Input from where? Like we said, standard input std in. That's where we want to read from. So flag.adds. We need to spread this. We need to spread it. Fantastic. So, but if we do have an error, don't forget to do this. So just do this one. And that we have the tags. This is the string there. We do todos.add task. And of course, it needs to be stored. So we go and store it. So looks great. So time to test. But for me to test it, I'll do go build cmd/todo. So I'll build the binary here. So to do add, let's add the first one after the code modification. Let's look at the to-do file. So we can see after the code modification, you can do to-do lists to also see it. Let me expand this. Great. How about now echo sending data from another program? Pipe our to do, and we need to pass the add flag. Fantastic, it came. Let me clear and then list sending data from another program. So as you can see, everything works. So we're almost done. Let's go back. Let's take a look at the code one more time. I think what is pending now is that print section for us to make it look pretty. And then we can add some refactoring and all that. Alright, to make it look pretty, we're going to need a third-party library. This is the first time that we're going to add a third-party library. So let me open my browser quickly and show you the library that we're going to add. It's a simple library that I think just worked. So this is it on GitHub. And I will leave a link to it on the description so you can see. You see, this is the table, and though as you can see, it doesn't have colors here yet. But if you go into the examples, for instance, you will see colorize, and this is where I found the code for the colors, and this is the constant. So we're going to bring some of this code over to our own code. So let me move this out, and then we should continue building. So the first thing is to do go get. All right, go get it, and I think we have it now. Let's look at the go mod. Fantastic, looks great. So let's go to our print. We should delete this one now. Let's create a table, simple table table.new. Right, so we need the header of the table. So table header will be equal to simple table header. Alright, so we need to add some cells to the header, which is it's a pointer to simple table cells. and this is where we add different cells. So first of all, let me put as an alignment to simple table alignment center. If you like, you can make it simple table dot align center. If you like, you can make it right or left or anyhow you want it. And then this is the ID, so we keep it this way. I would like to duplicate this, so we're going to have for about 4 ID, the task itself. We are going to have if it is done or not. We're going to have for created at, and we're going to have for completed at. Can I change this align right for this too? All right. So the next thing I want to do is the cells, which is the data itself. So I do var cells. Just point out to simple table cells. The same thing that we have here. All right. So let's look through our data. I will name it IDX or index, and the item range. You've seen this before with the reference, because you need to access the underlying data. Now that with the reference, we are going to increment this because we want the index to start from 1. And for now, I'm just going to do cells.append. I'll come and adjust this a little bit later. We are appending the pointer to a slice of simple table cells. All right, so it's very similar to what we have here actually, but I won't add alignments. So the test is I'll just put IDX for this. Remember, the first one is the number. Since it's an integer and it requires a string, we can do printf, printf, and pass it D to get the string version. Text is task this time around, so we can do item.task, and text is so done. We need something similar to do for formatting it, so item dot done. So this will be true or false basically. The rest I will do text item dot created, and I'll just do to string for now. It won't look that good, but it's no problem. Item dot completed dot to string, right? You can do format. Actually, let's do format and make it short. Format time dot let's look for one format here. Everything might make sense. Look for something that is short. I think it's really short here. Maybe this one. Yeah, let's take that. All right, so after the loop, we need the table body to be equal to simple table body, and then set the cells to our cells. This is what we just created, right? You remember we just created this, and then this is basically appending all this to it. Then we are setting it as the table cells. All right. We're almost done. Just to add the footer, table footer. We can do simple table footer. Cells. Everything is about cells. Pointer to simple table cells. And then align simple table align. So instead of me typing it all over again, I just copy this. Let's save some time. We want it to span all the rows, so I'll say span 5. And then text. For now, I will just say your to-dos are here. We'll come back to adjust some of these things shortly, but let's set style. It can be simple table style, like the Unicode style that I've tried, and look, and there are many styles that you can try as well. And then the last thing is just to print it. So look at the code quickly, then we can go and run it. Created an instance of the table, created the header, created the cells, and make it the body, and then the footer, and then print it. Right. So next is to run go build cmd to do. Since we have the to do files here, we'll just be able to run it as to do list. Wow, I don't know about you, but this feels great. Everything is coming out really nice, right? So the only pending thing is the column. So let's go work on the column. I'm going to put a file here, colors.go. So the colors, you know, remember I'm bringing, this is not like code I'm writing, but I'm basically taking it from the sample, so let me bring it back. So I'm bringing this from here, and this is the constant, and these are the color function. This is all we're taking from there, right? So we don't need to waste time doing it all over again. There's nothing much to learn here. Alright, so we'll go back to our to do into the print function, and let's start adding some of the adding colors to them. So the first place I want to add color is in here. So I will say task is by default the task will be blue. So item.task, but if item.done, then we'll change task to printf, and I'm doing this because I want to add something. I want to add the check mark, so I will change it to green. Bring out the string here. So this will be Unicode 2705 for that checkbox, and then our to do will be here item.task, and then we can replace this one with task. That is one. Let's run it and see. It's not working because we need to build and run it. Exactly, so everything is blue, but no to do marked as complete. So let's say complete. Let's mark the first one as completed, so we can go back now. What a code, working pretty well. Okay, another thing I want to touch is this section of the code where you have your to-dos here. So first of all, let's add a new method here called count pending. Func, I'll take the signature to save you some time. Count pending should return an int. Basically, let's do out. Sorry, total equals 0. For we don't need the index. Item equals to range with the reference the t if item is not done, we just increment total and we return total at this point. This is what I need in the print here to say read screencast. You have pending to-dos. So t.count pending. Alright, so let's build and run it again. Fantastic, so we have it. I think that's about it. You can, like, we can have like yes or no here, so let me quickly do that. I think it will look better if we have like a yes or no there instead. So I would say done, just no by default, and the no would be blue, no, and if it is done would be green, done will be green, yes. So done here, we can replace all this with done. And to build it, where is the command to build? And run the list. So it looks really good. Alright, so this is the app. Thank you so much for watching. My name is Joseph Abba. Please support me by subscribing to my channel. I'm creating more videos and I hope you enjoy this tutorial. There's a lot of improvement that can be made, especially with testing. The video is getting too long, so I'm going to stop now. Maybe I can do like a follow-up video and add tests to the code. Also, we need some refactoring here because of how many times we've repeated some of the code here in main, especially something like this. Another way to avoid this is to bring the saving into the like complete, for instance, but that is the function doing more than one thing, so it breaks the single responsibility principle, so I won't do that. But trust me, there's opportunity to refactor this code to make it cleaner, to make it shorter and all that. But this is it. So thank you once again and see you next time. Bye.